Railway has always been one of the most common mode of transport for carrying goods and various other logistics. The question which is proposed to us is that saying that a IoT device which is to prevent the underloading or the overloading of our railway wagons. Now the basic question which arises is that can a sensor like this can be developed which to detect the underweight or the overweight. From the year 2020 taken to 2021, there is an abrupt fall of our economy in which a basic pay holder pays for this wagon, which is showing a abrupt fall of our weight. Now we have come up with our sensor, which is totally devised to prevent the weight of the wagons up to a certain minimal level. Now going into the idea or approach, the conceptualization phase. It says about the AI-powered smart load sensor, which is actually fitted into the side of the tracks where it will be connected with a load cell, which will be user-friendly interfaced. Now going into our new technology, which is actually the RFID technology. This is actually the paint 3D analyzation of our wagon, which will give us the embedded picture or the geolocation, which will be automatically monitored or alerted, which can say the perfect real-time wagon which we are tracking about its weight or its functionalization. Now moving on to our next part, which is the cost reliable efficient part. The basic important message which we are throwing into our device is the cost efficiency for which we are carrying this project. Now I am going to abruptly make it valuable the cost efficient chart. So it will be carrying the design of a abruptly used load cell which will be of lowable cost and it will be fitted only on the two parts of our track which is shown in this given diagram. Now the load cell in the track is fitted with the Arduino Uno, which will be throwing the data from analog to digital converter and finally moving into the cloud. So we all basically know about the cloud, which is a wireless system, and it will be used for displaying our weight of the wagons. Now going into the dependencies or the showstopper. Before I read about the showstopper, I am going to present you the intro or the basic functionality of our wagon entry and exit sensors. To control the activation and also the deactivation of load cells, we have designed our wagon entry and exit sensor, which is a newly abrupt idea in our development modern feature. Now moving on to our next, or you can say the final slide, it gives us the important pointers. At first, the load cell will be fitted with an electric circuit, or as I've shown before, now we are running into the principle of how a load cell works. It actually contains the physics epitome principle of Wheatstone bridge, which is actually carrying the galvanometer fitted inside, which will cause diffraction as we receive the output in our binary resistance voltage. Now the question arises of security and also the privacy matters. So since it is a government affiliated project, we will be carrying the security through a data encryption method for securing the authentication and also controlling the access or the integral booster you can say. Now the proposed solution is operational efficiency, and as I have mentioned, it is cost efficient, promoting safely the data driven decision making, and also it is environmentally sustainable because we will be covering it with a polycarbonated system packaging which can actually prevent it from various atmospherical problems which generates in various days. As if you're throwing an example, the train is running through the track and an abrupt load has fallen into our device, but the polycarbonated covering will prevent it from such damage, and so it is both cost efficient and damage efficient. Now finally getting into our endpoint, which will be the document which totally discusses the implementation of our sequential load cell setup, where the multiple load cells are placed with the designated cost, and the setup will also contain the couple wagon entry and the real-time location, which will throw the data synchronization in a processed manner, and the cloud representation will be next shown in our hardware symptom, which I will be showing through our monitoring. Imagine a basic scenario of railway track in your mind. Here we have created a sample where we have fitted two tracks of the railway track, and here we have connected load cells along the track which is connected by congested appearance through a gum fiber. Now here we are fitting the load cell to absorb the strain or the pressure from the railway wheels, or you can say the wagon which will carry the load. Now if it is underweight or overweight, in both cases the strain will be absorbed by the load cell and it will throw it through the wires into the analog to digital converter, that is the ADC. The digital converter will then throw it into the Arduino Uno chip, which will record the exact measurement of the weight. Now the question arises where we are using the wireless version. This is the node MCU which you are calling the wireless version, which will be carrying the information, or you can say the real-time expressive value of our wagon, and convert it into the cloud, which we are showing through a previous video in which the red cell will indicate the overweight or a minority of our sensor. So the IT device which we have created, here the two pair of load cells are shown. But in the real-time value where we will be creating our device, we will be fitting more one pair of load cells, that is in total two pair of load cells, that is 4 versions. Why 4 versions? The wagon, say an abrupt example where the wagon will be of 60 meters in width. Now if the first 30 meter crosses, the value will be carried by our first pair of load cells and it will be processed to our cloud. And now when the second wagon's 30 meter will enter, it will be carried by our next load cells, which will be paired in this direction, which you can just imagine the basic scenario. Now, before entering our hardware functionality, the question arises why is the load cells fitted through the center? It is because to clarify the mass of attraction between the two load cells, to attain a proper sustainable pressure and give us the exact real-time appearance, or you can say the weight, through the iCloud manager. And here our initial weight was 1 kilo. As soon as I have used a weight of 38 kilo and put it over the load cell, or you can say along the track, it is changed to 39. And as soon I will be pressing another weight, or you can say putting another weight, it will again change to around 78, and you can see the change in the abrupt computer. Now the cloud structure we are using is ThinkSpeak, which is a newly generated modification to approach. Now as soon as it will jump over 100, the red circle will blink and it will show the overweight condition. As soon as I put another weight, now it has jumped to 118, and we can all see the blink of the red circle, which is indicating the overweight procedure of our wagon and thus detecting the overweight or the underweight.